We're going to take a look at the P-series, which is the third of the famous families of series that you've been working with. And the P-series looks like this. You call it a P-series because it has a power or an exponent in the denominator. For a big picture, realize that we have three famous families, the geometric series and the harmonic series, which you should know about already. We're doing the P-series right now. And these all have different characteristics or rules that can help you come to a conclusion of a convergence or divergence. And then later on, we will do other things, other tests for convergence or divergence when one of these famous families is not a part of the problem. So very simply put, if that exponent is greater than 1, this is a convergent P-series. If that exponent is less than or equal to 1, it's a divergent P-series. And yes, as a math lawyer, you must pay attention to this greater than or less than or equal sign. You will at times be perplexed by this borderline value of 1. We'll talk about that a little bit in this video. Well, let's take a look at some examples. First off, if I look at 1 over square root of n, you wouldn't necessarily think, hey, that's a P-series, but if you do a little eyeball adjustment and call that n to the 1/2 power, you realize you have an exponent in the denominator, you fit with the P-series, and then as long as you've memorized this rule, you say, hey, well, that's a divergent P-series, because my value of P is 1/2, which is less than or equal to 1. The AP would really like that answer. Here's another one. Now I put a numerator of 4 there. Realize that when you have a 1, you can have any number up top. And remember, I showed you in a previous video, if you feel like it, you can put that 4 out in front and have a 1 on top. Same thing. But I would identify this as it's a form of the P-series, and I would look at my value for P. My exponent is 2, and 2 is definitely larger than 1, so I have a convergent P-series. And that's a good justification. Now let's go a little bit of intuition, which can be dangerous, but the intuition would look like this. When I have a stronger denominator, if I were to start writing out the terms of this series, this denominator would end up being stronger as I wrote out each term than this denominator. If the denominator is stronger, then each consecutive term is going to be smaller and smaller and smaller, adding smaller and smaller values to the sequence of partial sums. So that's intuition that can help guide your thinking. The rough part about sequence and series is your intuition can be pretty logical, and you can still sometimes come to a wrong conclusion. Let's take a look at another one. Hey, that's a harmonic series. 6 over n, I have an exponent of 1. That's the harmonic series, so I automatically know it's divergent. But I can also look at that through a different point of view. I can call it a P-series with a p-value of 1. So it's a divergent P-series now. It's also a divergent harmonic series. It turns out that the harmonic series is just a very famous and special case of the P-series. So I briefly outlined some intuition that you would get as you compare these two series, and I want to now do it a little bit more formal. We got this one to be divergent based on the rules of the P-series, and this one to be convergent based on the rules of the P-series. But I'm going to back that up with an integral representation. As you may guess from a previous video, one way to come up with convergence or divergence is go ahead and do the integral. If you think this is easier or better than learning all those rules that we're starting to learn, then you go for that. Although I'm guessing you're not going to opt for that. But the improper integral in each case gives us the exact same conclusion. I guess I didn't write the conclusion here. Gives us the exact same conclusion that we would have come up with from the rules, but it's a good supporting proof or evidence to support our conclusion. All right, I guess that's it. Short and sweet. That's the end of the P-series video. Catch you later.